let us say that we have got two sets I and T, and I is the set of ice creams. I have vanilla, butterscotch and chocolate, and T is the set of toppings, choco chip, cherries and cranberries. So what I want to do in this video is motivate the idea of defining a relation between these two sets. So why is relation defined the way it is, and we'll be defining relation of course in the process. So the cross product of these two sets, I cross T, the Cartesian product, would be the whole set where the first entries would be from, so if I write it in the set builder form, it will be all the ordered pairs x comma y, where the first entry x is taken from the set I. So I would be in, let me write it in the same color, and the second entry y would belong to the set T. And this is the way I have defined Cartesian products. And what I want to motivate is the scenario where we don't use the whole Cartesian product. We might use a subset of it for our purpose. So for example, what will be the Cartesian product of this whole thing? Well, it will be all the ordered pairs. Because I know set I and set T and both are non-empty, I can write this in the roster form. So what do I have? I have V comma CC, the first ordered pair, V comma CH, vanilla with caramel, and so on. We'll have a few more elements. We'll have 3 more elements with butterscotch and 3 more with chocolate. So let me write down the last element the way I am ordering it. So chocolate comma caramel. So people don't choose to eat this, right? Chocolate comma caramel. People don't use. So people, we need to form a menu of some sort where we just want to work with a subset of I cross T. So say that I have a subset, let me call it R, and my subset contains all the people's favorites. So it might be something like vanilla comma choco chip, vanilla comma cherries. Well, vanilla goes with everything, but let me say vanilla comma cherries is not included in my menu for some reason, and I have butterscotch comma caramel and chocolate comma choco chip. A weird combo, but people seem to like this. So this is my new set R, and this is a subset of this whole set I cross T, and it might be useful in a lot of other mathematical scenarios too to just talk about this subset. So we call the subset a relation from I to T. So because our first set is I and the second set is T, so I depict it with an arrow from I to T. So let us now define a relation. Let me get a new page. Let us define what it means for something to be a relation. A relation given two sets. Relation from set A. I could have written just A also. Relation from A to B. So I'll write 2 here, but I'll be depicting with an arrow because this is how we usually depict relations. A relation R. So this is a arbitrary relation I'm going to define from A to T. This is how I write it, notation form, and read it as relation from A to B. So how do we define what a relation means? What a relation is? Well, I take the cross product of A and B, that is A cross B. I look at all the elements and I choose all the elements that are to my needs or that are to my liking. So it will be, a relation would be any subset, and I'll also call it non-empty because it doesn't make sense if none of the elements of A are not related to B. So I'll call it any non-empty subset. This is R is any non-empty subset of the set A cross B. So my A cross B would be a set, and I am taking any subset of that, of A cross B. And let me also impose a criteria that A and B have to be non-empty, because if either of those are empty, then our Cartesian product would not have any elements, because how do we define Cartesian products? We have done it here. So x comma y, so the first entry is from I and second entry is from t, and well, if either of the one is an empty set, then we'll not have any cross products. So this is how I'm defining a relation. Let us look at, this is pretty abstract now, but from the previous example one could figure out why is this the way we do it. And let us look at one more example, which is very famous in your syllabus. Wherever you read through relations, you look at this example. So there will be a set, let us take a set A of numbers 1, 2 and 3. Let's set B, B, A, B and C. And I am trying to define a relation from A to B. So I'll call it R1. Let me define a couple of relations from A to B just to be clear of the fact that relations can be arbitrary. So relation R1, I am defining it as the set 1 comma A. The second entry has to be from the second set, 1 comma B and 3 comma A, and that's it. This is the relation I want to consider. So what are the elements? Well, this is one way of defining it, one way of writing it, but as this might get a little bit messy and difficult to understand, we also depict it with two of these ovals to depict two sets. So this can be my set A of 1, 2 and 3. This is kind of like a Venn diagram for the set. Set B is A, B and C. Here the sets don't overlap, that's all. And I'm defining the relation, whichever ordered pair I found in the relation R1, I'll depict it by an arrow. So the element 1 from set A is related to A, so I'll put an arrow there. And element 1 is related to set B also, is related to the element B in the set B, and we have 3 comma A, so that has to be this arrow. So if you draw it neatly, it will be nice, but this would be a better way of depicting relation. So this is, what is this? This is R1, that is a relation from the set A to set B. So this is a nice way of doing it. It's just another way of writing the same thing in a diagram form. Well, I'm referring to set A and set B again and again during the course of explaining. So let me give a name to set A. Let me call it the domain of the relation, the place where the relation originates. So the domain of relation R1 is A, and let me call this the codomain, the place where the relation is taking the elements to. So this, I'll call it the codomain. So the codomain is my set B. The set where the second entries come from is called the codomain, and the set where the first entries come from is called the domain. We will get used to the terminology because I'll be using it very frequently. And let us look at further more examples to clarify this concept of relations in our coming videos. But let us just end with another relation on set A and set B, just to show that it can be arbitrary. So let me call it relation 2. Again, it is defined from set A to set B. So set A to B, and let the relation contain just one ordered pair. R2 is equal to 2 comma B, and that's all. That's all I have in my relation. So just 2 is related to B, and no other elements are related to no others. So this is set A, set B, and if I had to depict it with a diagram, A, B and C, and the only relation I have is from 2 to B. Let me draw a straighter line. So this is relation R2 defined from A to B. Here the domain is again A and the codomain is again B. Well, I hope this helps. See you soon.